Good day, critical thinkers, and welcome to today's class. So today we want to look at multiplication of surd. So we have that to multiply surds, you take whole numbers with whole numbers and surds with surds. Okay, these ones are whole numbers, or the ones under the root sign are surds. So you multiply whole numbers with whole numbers and then surds with surds. So and we have an example here about 5 questions. So let's go. So the first one is surd 5 multiplied by surd 10. And this is the same thing as surd 5 times 10. Because there's no whole number here. They are just, both of them are surds. So multiply. But then, looking at this number, we can go ahead and say 5 times 10 is 50. And we write it surd 50, right? But then we remember that after that surd 50 is not in its simplest form. We will still need to simplify it. So instead of going that back and front, so what we need to get here is, let's see if out of these numbers under the root sign, if we can get a perfect square and then a non-perfect square, which of course has no square root. And if you look at it very well, this is 5 already. 5 cannot further be simplified, but 10 can. And out of 10, we can still get 5. So from here, we can simplify. We can write this as square root of 5 times 5 times 2. Of course, 2 divides 10. We get what? 5. And this is the same thing as square root of 25 times 2. Now we've gotten a perfect square. So if you want to simplify further, add surd 25 multiplied by surd 2. And surd 25 is 5. So we have 5 surd 2 as a product of these two surds. Now the second one there is surd 30 multiplied by surd 5. And this is surd 30 times 5, right? And in the same method, if we might choose to multiply the 2, but then after, we will still go back to simplify it. So instead of going that way, we see if we can get 5 out of this thing. Maybe either of the two numbers. Of course, we know that if 5 goes in 30, 5 is not a perfect square already. So we check if the number that we get from dividing 5 with 30 is 5, is a perfect square. And of course it is. If 5 divides 30, we get 6. So this can further be written as surd 6 times 5 times 5, right? Yes. And this is equal to surd 6 times 25. And this is the same thing as surd 25 multiplied by surd 6. And this is equal to 5 surd 6. And the third one is simple, but we just write it. We have surd 2 all to the power of 3, and this is the same thing as surd 2 times surd 2 times surd 2, and which is surd 2 times 2 times 2, and which is surd 4 times 2. That is surd 4 multiplied by surd 2, and that is 2 surd 2. Number 4, we have surd 10 multiplied by 3 surd 2 multiplied by surd 20. Okay, now we have remember that it says multiply whole numbers with whole numbers and surd with surd, but here we only have one whole number, others are surd. So this is something as 3 surd 2 times surd 10 times surd 20, and which is the same thing as 3 surd 2 times 10 times 20. Now look at this number. Of course, we know that 10 can further be simplified, and 20 can also be further simplified. But then, if you look at 20, can we get another 10 from 20? And of course, we can. And when we get another 10, what will be left is 2. So that when we multiply that 2 with this 2, it's a perfect square, and that 10 with this 10 is another perfect square. So that is equal to 3 surd 2 times 10 times another 2 times 10. This 2 times 10 is from that 20. So from here now we have 3 surd 2 times 2 is what? 4. 4 multiplied by 10 times 10 is 100. So you see that we've gotten 2 perfect squares from that expression. So this is 3, of course, surd, okay, surd 4 multiplied by surd 100. And this is equal to 3 multiplied by 2, which is from surd 4, multiplied by 10, which is from surd 100. And this will give us 3 times 2 is 6 times 10, 60. The last one we have 2 surd 14 multiplied by 3 surd 21 all over 7 surd 24 multiplied by 2 surd 98. From the numerator, we have 2 times 3 times surd 14 times 21. Then from the denominator, we have 7 times 2, then times surd 24 times 98. And this is 2 times 3 is what? 6. Surd 14 times 21 all over 7 times 2 is 14. Surd 24 times 98. Now, we need to simplify, we need to get a perfect square from these numbers, and then it might be 2 or 3. The same thing from these ones, so that we can simplify them. Now, is there any number that can divide this and divide this? Is there any way we can get a perfect square? Number that can divide this and divide, so that when we multiply the 2, we have one of the perfect squares. We can get another one. That is okay. Now, 2 can divide this one, but 2 cannot divide this. 3 can divide this, but 3 cannot divide this. 4 cannot divide any. 5, no. 6, no. Now, 7. This is that 7 can divide 14, which is 2, and get 2. 7 can divide 21 and get 3. So, that is the same thing as 2. So, the first one is 2 times 7, then times 3 times 7. That is from the numerator. Now, coming to the denominator, we have one common thing that can divide both of them for now. If 2 divides 24, we get what? 12. And then if 2 divides 98, it's 49. So this can be written as 14 surd 2 times 12 times 2 times 49. That even right here, this 6. So let's bring it down. We have 6 surd 7 times 7 surd 49 times 2 times 3 all over 14 surd 2 times 2, 4 times 49 times, now 12. We can still get another perfect square out of 12, which is 4. It's 3 times 4 is 12. So we still have another 4 times 3. And that is the same thing as 6 surd 49 times 2 times 3 all over 14 Surd. Now, you see we have 4 here and 4 here. And when we multiply both of them, we get 16, which is another perfect square. So this is 16 times 49 times 3. And this is now 6 times. Surd 49 is what? 7. Multiplied by surd 2 times surd 3. All over 14 times, so 16 is what? 4 times 4. So 49 is 7. Then multiply by surd 3. Now, if you look at this thing, we can cancel out. Surd 3 cancel surd 3. 7 cancel 7. Okay, we have 6 surd 2 all over 14 times 4. And then we can still use 2 to cancel. If 2 cancel this one, we have 3. If 2 cancel this one, we have 2. Right? So we have 3 surd 2 all over 2 times 14 times 4, that is 28. So thank you for staying through to the end.